Today we are to discuss an example for the forward Newton-Gregory method. So this method is convenient in the determination of the equation of a given function and to determine the value of a given function at a given point. But for example, we have this set of data. We can use that method if we have a constant difference for the values of x. For example, we have 0 to 1, this is 1, 1 to 2 is also 1, 2 to 3 is 1, 3 to 4 is also a 1 difference. We have a constant difference between the values of x. Then, for example, we are required to determine the equivalent of f of 0.5 and f of 1.5. So let's have the values of x. This is at x is equal to 0, and the value of f of x is 1. At x equal to 1, and the value of f of x is 7. If the value of x is equal to 2, we have this is 23. At x equal to 3, this is 55. At x equal to 4, this is equal to 109. So this is our forward difference table. We are looking for the equivalent of f of 0.5 and f of 1.5. As you can see, 0.5 and 1.5 are before these values. Our mean value or middle value is 223. So if we are looking for these values just before our middle value or our mean value, therefore we can use the forward Newton-Gregory method. Okay, then we have to complete our forward difference table. So this is 7 minus 1. We just take the difference for the equivalent of delta f of x. 7 minus 1 is 6. The next, 23 minus 7 is 16. Then next, 55 minus 23. What is 55 minus 23? This is 32. Then 109 minus 55. 109 minus 55 is 54. So that will be the equivalent values of delta f of x. Then for the next differences, we are just to repeat the process. This is 16 minus 6. We have that as 10. 32 minus 16 is the same as 16. Then we have 54 minus 32. This is 4 minus 2 is 2. 5 minus 3 is 2. This is 22. So that will be the equivalent of the values for the delta squared f of x. Then for the delta cube f of x, this is 16 minus 10 is 6. 22 minus 16 is the same as 6. Then for the last difference, 6 minus 6 is 0. So we may stop on the third column on the delta cube f of x for this column, since their next difference will be 0. So applying the formula for the Newton-Gregory forward Newton-Gregory method. So that is, for example, we have to determine the equivalent equation of the function. So that is y. Our initial value f of x. Plus, we need the value of r. This is multiplied by the delta f of x. That is the next column. Plus. We have r divided by r minus 1 divided by 2 factorial. This is for the next column. This is delta squared f of x. Then plus, since we may stop on these columns, since their next difference is 0, we may stop here. This is plus r divided by r minus 1 divided by r minus 2. This is divided by 3 factorial divided by delta cube f of x. And so on if, for example, we are to extend the differences. So if we are to determine the equivalent of the function, so this is, we have y. First, we need to determine the value of r. In some references, they're using r. Other references, they're using p. But this is the same as x minus x of 0 divided by the step size. For the step size of the values, for the values of x, this is the same as h. 1 minus 0 is 1, 2 minus 1 is 1, 3 minus 2 is 1, and so on. So if you are to input the equivalent of r, this is the same as x minus x of 0. What is our initial value of x, or the first value of x? This is the same as 0. Okay, divided by 1, so therefore this is the same as x. Now if we are to input these values to our equation, that will be y is now equal to f of x, that is the same as 1. Okay, for example, we are to take this set of values. So it's the same as 1 times plus, what is the value of r? The value of r is the same as x. What is the value of the delta f of x? That is the same as 6. Okay, plus, and then next term, this is x multiplied by x minus 1 divided by 2 factorial multiplied by delta squared f of x. Delta squared f of x is, this is 10. Okay, divide plus. Then yung next, the next term, this is r. What is the value of r? That is the same as x times x minus 1 multiplied by x minus 2 divided by 3 factorial delta cube f of x. That is the same as 6. Then we are just to simplify. We simplify that one. We have now y is equal to, this is 1 plus 6x. What is the equivalent of 2 factorial? 2 factorial is the same as 2. 10 divided by 2, that will be the same as 5. So that will be the same as 5x times x minus 1. Then plus, what is the equivalent of 3 factorial? 3 factorial is the same as 3 times 2 times 1. That is the same as 6. So 6 over 6, that will be this, that will be cancelled. 6 will be cancelled. So we will be having x multiplied by x minus 1 multiplied by x minus 2. Take note, okay? Here we have the equivalent of 2 factorial is 2, 3 factorial is 6. So we have an equivalent of y. If we are to simplify this one, this is 1 plus 6x plus 5x squared minus 5x plus, this is x multiplied by x squared minus 3x plus 2. Or we have the value of y is equal to 1 plus 6x plus 5x squared minus 5x, okay, plus distributing x, this is x cubed minus 3x squared plus 2x. Alright, then we have the final equation, y. Let us have the x cubed first. Then 3x squared plus 5x squared is plus 2x squared. Then we have 6x minus 5x is x plus 2x, that is the same as 3x. Then plus the constant 1. So this is our equation, or the equation of this of the polynomial. Okay, then initially we are looking for the value of f of 0.5 and 1.5. So we have f of x. This is f of x, or the same as the y function, is equal to x cubed plus 2x squared plus 3x plus 1. So let's have the equivalent of f of 0.5. This is 0.5 raised to 3 plus 2 times 0.5 squared plus 3 multiplied by 0.5 plus 1. So let's have the equivalent of f of 0.5. And that is 0.5 cubed plus 2 times 0.5 squared plus 3 times 0.5 plus 1. So we have the value equal to 3.125. Then what about f at 1.5? All we have to do is substitute this value to our equation. So that's the same as 1.5 raised to 3 plus 2 times 1.5 squared plus 3 times 1.5 y plus 1. Okay, so let's have the value of the equivalent of f of 5. That is 1.5 raised to 3. Okay, plus 2 times 1.5 squared, then plus 3 times 1.5 plus 1. And we have that value. We have f of 1.5 is now equal to 13.375. Okay, so those are the requirement, f of 0.5 and f of 1.5.